Continuing on in lesson 2.6, absolute value and piecewise functions. Absolute value graphs, and you've dealt with these in the past, are always V-shaped. Not a parabola, but V-shaped, meaning straight line segments that form a V. Anything with absolute value, doesn't matter if it's just the absolute value of x, which is the one we're going to look at here, or if you have operations inside or outside, it's going to produce a V shape. Okay, this is kind of the main V-shaped graph, and then when you start adding or subtracting outside, multiplying by it, that adjusts the V, it shifts it over, might widen it or narrow it, but anything with absolute value is going to be V-shaped, and you need to make a table. So we're going to make a table here for y, or remember this is like y equals absolute value of x. So if I did a table here, x and f of x, I'll pick some negatives and some positives. So negative 3, negative 2, negative 1, 0, 1, and 2, and 3. So if I plug negative 3 in, the absolute value of negative 3 is 3. If I plug negative 2 in, the absolute value of negative 2 is 2. If I plug negative 1 in, because we're just doing the absolute value of x, that's 1. 0 would be 0. Absolute value of 1 is 1. Remember, absolute value is always positive. The absolute value of 2 is 2. Absolute value of 3 is 3. If I plot these points, negative 3, 3 is right here. Negative 2, 2 is right here. Negative 1, 1. 0, 0. 1 positive 1, 2 positive 2, 3 positive 3. And I said it's going to be a V-shaped. Anything with absolute value is a V-shaped graph. Okay? Piecewise, a piecewise function has multiple parts. My suggestion, it's going to have at least 2 parts. Sometimes it has 3. It has pieces. That's what it means. Multiple parts. Make a table for each part. So, here's what I mean. We're going to make an XY table, and it's f of x or y is equal to negative x for x values less than 0. So I'm going to put, I know it says less than 0, what we're going to do is we're going to put 0 in, and this is just going to mean that it is an open circle at this point for this part of it, because it's only less than, but we have to think about the decimals in between 0 and as we get smaller or less than that. So at 0, if I plugged it in, I take the opposite of 0, that's 0. So that's going to be an open circle there, and then I want to pick values less than 0 right here. So let's pick negative 1, and we don't have to pick decimals in between unless you want to. On the greatest integer function you have to do that, but here I'm taking the opposite of x. So that would be positive 1. The opposite of negative 1 is positive 1. The opposite of, let's go negative 2, is 2. The opposite of negative 3 is 3. And this would continue going on like this. So at 0, 0, we're right here. At negative 1, 1, we're there. At negative 2, we're up at 2. At negative 3, we're up at 3. Okay, and this, I said we had to draw an open circle, but we actually would do an open circle right here for this part. Now, we're going to make a table for this part right here. It is f of x equals x for x values greater than or equal to 0. So we're going to put 0 in. Now, this would actually be a closed circle. Well, I'm basically saying y is equal to x right here. So if the x value is 0, the y value has to be 0, which would make it a closed circle. Now, it just happens that this open circle from the left piece and the closed circle from the right fill that in. So in this case, a lot of times you might be at a different part, above or below that open circle. At 1, we're equal to it. We're at 1. 2, we're at 2. 3, we're at 3. So 1, 1, 2, 2, 3, 3, and it's going to look like this. Now, if you notice, this piecewise and add this absolute value, the graphs look the same. Okay, and this is just an example of a piecewise being the same graph as an absolute value. That doesn't happen usually. Usually in this, you're going to get different pieces. They may not be connected. In this case, it happens to be connected. Let's list the domain and range. Now, these are actually the same graph, so the domain and range are going to be the same for both of these. The domain is what x can be. This goes infinitely out in the left and right direction, so it's all real numbers. So it's all reals. Now, the range is the y value. Notice the lowest y value graphed is 0. and then we have all numbers greater than 0. So the range would be the set of all y's such that y is bigger than or equal to 0. For either one of these graphs, there's your domain and your range. Got another absolute value one here. F of x is equal to x minus 3. Absolute value, automatically that tells us it's going to be a V-shaped graph. So let's pick some values here. Let's pick negative 3, negative 2, negative 1, 0, 1, 2, 3. Now what happens when you start adding or subtracting values inside absolute value, or outside for that matter, it starts to adjust where the point of your V is going to be. Okay, so you got to keep going till you get the V where it's going to V back up or V back down depending on if it's an upside down V. But if I put negative 3 in, negative 3 minus 3 is negative 6. The absolute value of negative 6 is 6. If I put negative 2 in, negative 2 minus 3 is negative 5. The absolute value of negative 5 is 5. Negative 1 minus 3 is negative 4. Take the absolute value, it's 4. Put 0 in, 0 minus 3 is negative 3. Absolute value is 3. Put 1 in. 1 minus 3 is negative 2. Absolute value is 2. Put 2 in. 2 minus 3 is negative 1. Absolute value is 1. 3 minus 3 is 0. Absolute value is 0. So if you notice this first part, we had negative 3, 6, negative 2, 5, negative 1, 4, 0, 3, 1, 2, 2, 1, 3, 0. We haven't gotten to, it's not a line, okay, because it's got absolute value in it. We haven't gotten to the point where it V's, but let's keep going here. Let's put 4 in. 4 minus 3 inside absolute value is 1. The absolute value of 1 is 1. So now we're at 4, 1. See how it's starting to V back up? At 5, 5 minus 3 is 2. Absolute value is 2. Starts to V back up. And so here's what's going to happen. At 6, it would be up there. So notice we had to keep going till we got to that V part. Let's list our domain and our range. Domain goes infinitely to the left and infinitely to the right, so that's all reals. It's a connected graph. The range, basically it is, the smallest y value graph is 0. That's 0 and above, so the y value is greater than or equal to 0 would be your range. All y values greater than or equal to 0. What happens is this has shifted that first absolute value graph we did 3 units to the right. Notice instead of at 0, 0 for our point of our V, we're at 3, 0. And that's what happens when you add and subtract things inside there. All right, now we got a piecewise here. 2 pieces. 1 part, 2 parts. So what I suggest you do for all piecewise ones, even if they have 3 parts, is make a table for each part. So there's what it's equal to. For the 1 part, the other part, f of x is equal to 1. And this is for x values bigger than 3. This is for x values less than or equal to 3. We're going to make a table. X, f of x, which is just like y. Remember, this is just like y. So this tells us we want to start looking at x values less than or equal to 3. So I'm going to put 3 in there. So we're going to start with 3, and then we're going to go smaller than that. If I put 3 in here, 3 minus 1, if you notice, this is in mx plus b form, so this part of it's going to be linear. 3 minus 1 is 2. Okay, but I want to go smaller than 3 now, so I'm going to go 2. Because this says I have to pick values less than or equal to 3. If I put 2 in, 2 minus 1 is 1. If I put 1 in, 1 minus 1 is 0. If I put 0 in, negative 1. If I put negative 1 in, negative 2, and it would be so on. So we're going to need to put an arrow out in this direction. This right here, because the equal to part is on this symbol, is going to be a closed circle. Because we have the equal to part on it. So at 3, 2, we're closed. Then we're at 2, 1. Then we're at 1, 0. Then we're at 0, negative 1, so it's going to be a closed circle, and it's going to start going like that. And it's going to go on forever that way. It stops right here, though, at 3. Okay, because now this is a constant. It's like y equals 1. And actually, in your notes, I just noticed this should actually be negative 1. Okay, for some reason on my smart board it's not, there's no negative sign there. So it's -1. So when we make the table here, x, y, or f of x, we are going to pick x values bigger than 3. Now, I'm actually going to put 3 in here, even though it says x is bigger than 3. This just means it's going to be an open circle right here. Okay? So at 3 we're at 1, and we're going to go bigger. 4 we're at 1, 5 we're at 1, 6 we're at 1, and so on. It's going to continue on in that direction. So at 3, I'm sorry, it's -1. I just changed it to negative, and then I forgot to do it in here. So these are at -1. So at 3, we're at -1, and that's going to be an open circle because in between, like at 3.1, 3.2, we're down here at -1, and then it's going to be an arrow going that way. So key thing with piecewise is to make a table for each part. Okay, notice this is unlike that last piecewise in that we had it connected. Here we have pieces, and a lot of times if you have 3 different parts, you might have 3 different pieces. Let's do our domain and range. Domain, this goes infinitely to the left and infinitely to the right. We just have a closed circle there and an open circle below, but really it is still all real numbers. The range is what? What y values are graphed? Now, on the constant part of the graph, we have -1. Well, that's really graphed on the left part of the graph here that is a decreasing segment there. So pretty much the biggest y value graphed is 2, and then it's everything below 2, and that includes the constant part of the graph. So if we just said y is less than or equal to 2 for the range, that would be correct. And that really describes the left part of the graph, but -1 y values are included in how we state that y has to be less than or equal to 2. So make a table for each part. Determine whether each graph represents a step function, a constant function, an absolute value function, or a piecewise function. Okay, obviously this one is horizontal line, so this would be a constant function. This one is V-shaped, so this has to be absolute value. You saw what piecewise ones look like. If you have any parts to them, okay, they're disconnected a lot of times, or if you have a step function, they're little mini steps. And that completes lesson 2.6.